Welcome back to Study On. So you were solving a linear programming problem with the in operation research subject, and we have discussed about the problem and its constraints. We have modeled the equations, and now we are going to construct the model. Right? We have to prepare a model in which there will be the objective function subject to all of the constraints that we are faced with. So the objective is, in last, we have to drive a particular number of interior pen and exterior pen that we will suggest to company that this these, if you produce these amount of exterior pens and these amount of interior pens, you will generate a maximum profit. So that's our objective. All right, so for now we are going to construct the model. So in construction of the model, the necessary step is to bring all the equations that we have together at one place. So now maximize z, that is the objective function, that how we represent this 5xe plus 4xi, which is subject to all of these equations that we have, or the constraints. You can also call them constraints that we are available with. So all of the constraints are put in an order, like xe with xe under xe and xi under xi, and the values together. And in last we have the non-negativity constant that was also there, and then we can label them as equation number 1, equation number 2, 3, 4 and 5, which will be helpful in later on when we will be making graphs. So now we are solving the equations to obtain the feasible points. Now feasible points are very important because with these we will be able to find out our solution. So the first equation, we are going to solve the first equation, LP equation. So it's called LP equation, linear programming or linear equation, because it's having only two variables, right? 1 and 2 variables, and also it has no exponents with it. So such a case is called as a linear equation. So now we are going to solve it. Now we don't have the values of xe or xi to put. So what we will do, we will assume xe, xi, and in the first place we will consider xe is equals to 0, and we will obtain the value of xi. So let's see how we can do it. If we start solving the problem and put the value of xe 0 plus 4xi equals to 24. This becomes 0, and xi is equals to 24 upon 4, and 4 6 are 24. So xi is equal to 6. So you see that by making xe 0, we got xi is equals to 6. Now in the other place, what we will do, we will make xi 0 and we will be obtaining value of xe. So here we are putting the value of 6xe plus 4xi equals to 0 is equals to 24. So this whole term becomes 0, only 6xe remains behind, and 24. So xe is equals to 24. We are bringing this number at the denominator's place. So 6 1 are 6, 6 4s are 24. So xe equals to 4. Now we are here available with the value of xe by making xi 0. So we are going up, and you can see the value of xe has come 4. So in first place, when we made the value 0, we got xi 6. When we made the value of xi 0, we got 4. So we have got the following coordinates, xe comma xi. So in the first place, we have got 0 comma 6 and 4 comma 0. So these points will help us when we will be making a graph. So we have obtained the values, and similarly this way I have solved the other equations as well. Similarly, equation number 2, where you can see xe plus 2xi is equals to 6. So first I have made xe's value 0, and by doing so putting 0 at x's place, I have got the value of xi, which is 3. So in the first coordinate we have got 0, 3, and the other we have got 6, 0. So similarly, we have done rest of the equations assuming first, variable 0 and then second variable 0. So we have obtained the two values from each of the equations, and equation number 3, you can see equation number 4, we have got xi is equals to 2, because already it is when we put equal to sign it becomes equal. And then now we have in the last step is to put all the points on the graph. Let's learn how to make a graph on a separate paper. We are taking this graph which has 4 coordinates, because we have one negative value as well, and I'm quickly marking it with the pen in equal, making possibly equal distances as neat as I can. 1, 2, 3, 4, 5, 6, 7. Okay, I think it's enough. 1, 2, 3, 4, 5, 6, 7. And here it is 0 and -1, -2, -3, -4. This much is enough. Now I need points to make up my graph. So the points that I have obtained from solving the equations are 0, 6 and 4, 0. I'm quickly noting it down. 0, 6 and 4, 0. So because it will help me to plot my points. And 0, 3, 6, 0. Then I have 0, 1, -1, 0. Then I have 0, 2. Now time to plot it. Okay. So the first point is 0, 6. 0 is on x-axis, y is on, 6 is on y-axis. So I'm plotting 0 here, suppose, and from equation number 1, and 6 on the y-axis. So 6 is here. Okay, so I have marked it here, 6. Then again from the same equation I have two other points, 4, 0. So 4 this time is on x-axis and 0 is on y-axis. So I'm moving to the x-axis. This is x-axis, this is y-axis. So on x-axis I have to plot 4. So I'm going to 4. Here is the 4, right? Here is the 4 and here is the 6. So we can make a line crossing 6 and 4. So let's take a line, and simply I'm just going to cross it through 4 and 6. Alright, so this line I am labeling as line 1, or you can say it as the equation number 1. Then we have equation 2, where we have 0, 3. So 0 is on x-axis. No need to mark. 3 is on y-axis. I'm marking 3 over here. Mark 3 over here. Then I have 6 and 0. So 0 and 6. 6 here. Again, a line can be made. So take a line, take your ruler, and create a line that can run through these points. Okay. And I label it as line 2 or equation 2. Then I have, so line 1 is done, line 2 is done, line 3, 0, 1, -1, 0. Again 0, 1, 1 is on y. So here I'm pointing 1 and -1, 0. So minus means we are moving to the left side of the x-axis. It's horizontal, it's x-axis, but it is minus, so we will moving this side of the y-axis. So there is a -1, so marking it, and again we can create a line that runs through both of the points. here, and I label it L3, right? And it has come from equation 3. Then I have equation number 4, which is 0, 2. So 0 here and 2. 2 is on y-axis. This is x-axis, this is y-axis. So here on 2, and there is no other point. So I will make according to that, we will make a horizontal line which runs from this area straight. All right. Having done this whole thing, you will be seeing here that there is a closed region that is being created. Where is the closed region? Let me highlight it. Okay, so you will be seeing a space which is enclosed. This space, this region is enclosed, and this enclosed region we call as a space of feasible region or feasible space. So simply we will label it as a feasible space. Now out of this feasible space we have to take out feasible points, and we will take out the feasible points with the corner points A, B, C, D, E, whatever the corner points have been made. So how we can make the corner points? So you will see that wherever the lines are intersecting, we can make the corners. So as I've labeled over here that the lines are intersecting here, I have labeled as A, and if you will see the other line is intersecting this x-axis line, so I will label it as B, the corner B, and again you will see the next line is intersecting here, the lines are crossing and the edge is made, so I am labeling here C. Another line is intersecting to this point, I'm labeling it as D. Here again you can see the lines are intersecting, so in this closed region wherever the edges are made, I can label them with alphabetically E, and again I'm seeing another line is intersecting here, so I am labeling it F, and until you reach A. So this is a closed region. This is a closed region in which our solution is lying. So we have to find out that whichever from these corner points is our solution, or where our solution is lying. All right, so how we can do that? We can first find out the corner points from this image or the closed region that we have made. So there are A to F corner points. We will be writing the values of the corner points over here, quickly writing them down. A, so because A is lying on 0, so both values for the 0 x and y axis will be 0. B corner point, so you can see that B is lying on number 4, so we are writing 4, and again there is no y axis for it, it's 0. C is here. You can see that the value of the C is coming towards 3. It is basically 3, but when you will solve it on a graph paper, it will be more accurate. I have done it manually. So anyways, it is 3. And the value of the C for the y coordinate we cannot find out because it's lying between 2 and 1. So there is a way to find out the value of C when we are unable to visibly cannot decide that which value it is, so we can always solve it with the simultaneous equation. I will show you how, but for now we are writing the value of D. So you see the D is on 2, and on the graph paper it's again on 2, so we will write here 2 comma 2, and then D is E. After D there is E is already 2 and 1, and F is lying on y-axis, it is 0 and 1, right? So we are coming back, and we are seeing that this is solved accordingly, and for finding out the value of the C, you have to solve it according to simultaneous equation. The lines that are crossing C, okay, so there are two lines that are crossing C. If you see in the screen, the C has line 1 crossing and line 2, which is equation number 2 and equation number 1. So we will take both of the equations and we will solve them according to simultaneous equation. Okay, so what we will get the value of C, which is according to it is 1.5. So anyways, after putting the corner points in the objective function, we will get this final result, where we will suggest the company about its productivity. We will say that these are the units of interior pan that you should produce. These are the units of exterior pan that you should produce to maximize your daily profit, which is by 21,000 when you will multiply them. So I hope this was helpful to you. Thank you. Allah Hafiz.